Today's lesson is proving triangles congruent by side, 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 and hypotenuse leg triangle congruence. Okay, so we've already covered that I can prove two triangles are congruent when I have three pairs of angles congruent and three pairs of sides congruent. But I don't necessarily need all 6 parts to prove my triangles are congruent. I can prove triangles are congruent with just 3 parts of the 6. But they have to be in a specific order. So one of the types of orders is where I have all 3 pairs of sides, and we call that side, side, side triangle congruence. So I'm specifically looking for the same number of tick marks. I am looking at if I have shared sides, or if there's numbers, the numbers would tell me they're congruent also. Okay, so let's do a theorem here. We are going to write a proof. I want to prove that my 2 triangles are congruent with the given information. Okay, so my given information, I am going to list in my statements. So segment KL is congruent to segment NL, so KL and NL. And segment KM is congruent to NM. These 2 are congruent. And I list those in the statements. Next, I have given. So I put those as my reasons for the information that I'm starting with. And I am proving, this is what I'm doing, so I don't ever write that, but I'm trying to prove that these 2 triangles are congruent. So I put that as my last statement. Okay, so I see that I have, this is one of the 3 pairs of sides. This is another of the pair of 3s of sides. So I'm actually just looking for the 3rd pair of sides. And I see that I am sharing this side. So this would be my 3rd pair of sides. So I would say LM, segment LM, is congruent to segment LM. And I call that the reflexive property of congruence. Okay, we've seen this quite a few. Anytime something is equal to itself, we call that the reflexive property of congruence. So now I have 3 pairs of sides, so I call this side, side, side triangle congruence. Okay, so let's check. Decide whether the congruent statement is true, and I want you to explain your reasoning. So if I look at number 1, is triangle DFG congruent to triangle HJG? And I would say yes. And the way I'm going to say that is this is by side, side, side triangle congruence. So I have 3 pairs of congruent sides. And number 2, triangle ACB is congruent to triangle CAD. So 1 pair of sides is 7. Another pair of sides would be 9. That's a shared side. But 3 and 4 are not the same. So I just really have side, side. So since I don't have all 3, I'm going to say no, these triangles are not congruent. So what about the last example? I have 3 sets of congruent, so yes, this would be side, 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 triangle congruence. Okay, so another way I can prove triangles are congruent with 3 pieces of information is called hypotenuse leg. So hypotenuse is the name of the side across from a 90-degree angle. So while I really sound like I only have 2 pieces of information, the third piece of information is that I have a 90-degree angle. So again, for sides, I'm looking for tick marks and shared sides. And one angle has to be a right angle is what we're looking for. Okay, so let's do a proof here. So the information I'm given is, I have a lot of information here. Okay, so I'm going to put the first piece that I'm given, that WY is congruent to XC. And I have some perpendicular information. So that's telling me I have right angles. So I put that information in the statements. Whatever I'm given to begin, those are the reasons I put. So I have, these are my reasons. And then I am proving, this is what I'm doing. And I put that as my last statement. So I'm trying to prove these 2 triangles are congruent. All right, so I'm going to say, since I'm going to go through how I'd go through this. And WZ is perpendicular to ZY, tells me I have a right angle. Perpendicular tells me I have a right angle. And XY is perpendicular to ZY. So that's telling me I have a right angle. So I would write this, that angle Z and angle Y are right angles. So angle Z and angle Y are right angles. Okay, so all right angles are congruent. So then I can say angle Z is congruent to angle Y. That's the definition of a right triangle. Okay, so here's my 90-degree angle. I said I had to have 2 congruent sides. So here's one pair of sides that are congruent. And I have to have a 90-degree angle. Oh, so which side is this? Is this the hypotenuse or the leg? So the sides given are across from 90 degrees, so that's the hypotenuse. So the last thing I need to do is name a leg. So I can either name this leg here, YZ, or the other legs, WZ and XZ. But since YZ is what's in both of them, that would be the one. So that's what I'm calling a shared side. So this leg is going to say YZ is congruent to YZ. Anything that's congruent to itself, we call that reflexive property of congruence. So now I have my 3 parts in my specific order. I have a 90-degree angle, the hypotenuse, and a leg. So I can say my 2 triangles are congruent by hypotenuse leg triangle congruence. And we are done.